We are going to learn just a little bit about interval notation. And before we begin, we have to define some symbols. So the first symbol we're going to look at is this symbol right here. It is known as the less than symbol. And the reason it's known as the less than symbol is, as you can see, the smaller side will always point to a smaller number, and the bigger side will always point to a larger number. So, for example, you could use the statement that 2 is less than 5. That is a true statement because the number 2 is on the smaller side of the less than symbol, and that is smaller than the number 5, which is on the greater sign of the greater than symbol. Similarly, there's a symbol called the greater than symbol, and the way that this symbol works is that the larger number is on the left and the smaller number is on the right. So for example, the statement 8 is greater than 3 is a true statement. There's also a symbol known as the less than or equal to symbol. And this symbol is used when the number on the left is either less than to the number on the right, or the number on the left is exactly the same as the number on the right. So let me give you some examples of those true statements. So for example, 5 is less than or equal to 7 is a true statement. You could also say that 8 is less than or equal to 8. Now the number on the left, 8, is not smaller than the number 8, but it is equal to. So the fact that that equal symbol is there means that this statement is true. Similarly, there's a greater than or equal to symbol. And as you might imagine, that means that the number on the left must be greater than the number on the right, or the number on the left could also be equal to the number on the right. So some examples of true statements here are, for example, that 10 is greater than or equal to 2. That's true. Certainly, we could also say that 3 is greater than or equal to the number 3. That's also true. We could also say something like 2.0001 is greater than or equal to 2. That is also true. And the last symbol that we will introduce looks like a sideways 8, and that is known as the infinity symbol. And if we think about a number line for a minute, you have 0 in the middle of the number line, you have some positive numbers, and those numbers go on forever. Then you have some negative numbers, and those numbers also go on forever. But to indicate that they go on forever, we use the symbol infinity. So we say that 1, 2, 3, 4, 5, eventually we're going to get to the idea of infinity. And similarly, if we go to the negative side, we go 0, negative 1, negative 2, negative 3, and so on. Eventually we're going to reach negative infinity numbers. Now, because infinity is not a number itself, it's just a concept. So keep that in mind. That's going to become relevant in just a couple of minutes. The infinity symbol represents the concept of numbers going on forever. Now we're going to learn how to use these symbols and to graph. So on the left here, we have an inequality that x is less than or equal to the number negative 3. Now, as you recall, this means that the values of x must be smaller than or equal to the number negative 3. We can graph that on a number line, and we'll do that here in the center. So the way you indicate that numbers are smaller than or equal to the negative 3 are by putting in a bracket symbol. That bracket symbol means that the number negative 3 would also be less than or equal to itself. And then you shade in the areas representing x. So the x's are less than or equal to the number 3. That means we shade in the left here because that's where the numbers that are smaller than or equal to the number negative 3 are. If you look at the problem here, we find that the numbers x are smaller than the number negative 3. The difference here is that there's no equality under the less than symbol. And so if that's the case, instead of putting in a bracket, we're going to put in just a parenthesis there. So this indicates all the numbers that are smaller than the number negative 3. The difference is that the brackets, with the square brackets, include the number negative 3. So that would mean that negative 3 counts as part of that interval. On the bottom side, we don't have an equality symbol, which means that the number negative 3 itself is not included in this interval. But anything really close to negative 3 would be included. So for example, negative 3.00001 is part of that interval, and that's why we use a parenthesis to say that we're going to get really close to the number negative 3, but never actually touch it. The next piece that we're going to do is we have taken this inequality, graphed it on a number line. Now we're going to write it in what we call interval notation. It's just another way to annotate what has happened. So in order for that to happen, remember that on your number line, all the positive numbers go all the way to infinity, all the negative numbers go all the way to negative infinity. So in the interval notation, we're simply going to represent the shaded area. And the shaded area from smallest to greatest goes from negative infinity all the way up to negative 3. Notice that we included the number negative 3, so we're going to use a bracket there. As far as infinity goes, we never include infinity because that is a concept, so we use a parenthesis there. On the bottom example, again, remember that there's a negative infinity on the left side of this number line and a positive infinity on the other side of this number line. We're going to represent the shaded area in an interval. So the shaded area goes all the way from negative infinity all the way up to the number negative 3. But we do not include the number negative 3, and we never include infinity because it's a concept, not a number. Now let's take a look at these examples using the greater than symbols. So on the left here we have that x is greater than or equal to the number 2. So again, what values of x would be greater than or equal to the number 2? If I look at my number line here, those would be the values to the right of the number 2. Those values are greater than or equal to the number 2. How about the number 2 itself? Would putting 2 into this x variable make the statement true? And it would. So what we do is we put a bracket there to show that the number 2 is included in this interval. Let's look at the bottom inequality. We have that x is greater than the number 2. So this one has no equality. So again, we shade the values of x that would be greater than the number 2. So that would be everything to the right of 2. I'm going to shade that. And again, we ask the question, how about the number 2 itself? The number 2 itself is not included in this interval. X has to be strictly bigger than 2. So we use a parenthesis here to indicate that 2 itself is not included, but the very next thing next to 2 is included. So for example, 2.5 would be included because it is bigger than 2. The next step would be to show these intervals, but in interval notation, these graphs in interval notation. So again, remember that to the left of the number line there's a negative infinity, to the right of the number line there's a positive infinity. So there's a negative infinity on the left and a positive infinity on the right. So this interval up here would be the interval from 2 to infinity. We include the number 2, but we never include the infinity. On the bottom here, again, it's the same interval 2 to infinity, but the inclusion symbols are different. We do not include the number 2 here, and we never include infinity. Sometimes we have what we call a compound inequality. And a compound inequality is an inequality that's trying to say more than one thing at the same time. So take, for example, these two inequalities here, these two restrictions, the fact that x has to be bigger than or equal to the negative 1, but x must also be less than 4. So in order to understand what's really happening here, let's graph what's going on here. So let's first graph the fact that x is greater than or equal to negative 1. So if x is greater than or equal to negative 1, remember we shade all the numbers that are bigger than negative 1. But x must also be smaller than the number 4. So I need to stop here at 4. Let's see what symbols of inclusion we use here. So for x is greater than or equal, we're going to use a bracket. Let me make that a different color actually. For x is greater than or equal, we're going to use a bracket. And for x is less than, we're going to use a parenthesis. Remember, the bracket is used to show that there's an equality there. The parenthesis is used to show that the number is not included. So because both of these statements must be true, that's why it's only that middle shaded area there. So then this interval would be the interval from -1 to 4, where -1 is included in the interval because x is allowed to be equal to -1, but 4 is not included in the interval because 4 must strictly be less than, x must strictly be less than 4. And we do remember that there are infinities here, but because this interval doesn't extend to infinity, we don't include it in our interval. Another way to indicate that x is greater than or equal to -1 and that x is less than 4 is in this notation, compound notation, which means that -1 is less than or equal to x and x is less than 4. We're saying both of these things that we're saying up here in just a single statement. Sometimes two statements can't be true at the same time. So for example, take this x is greater than 3 or x is less than or equal to 1. Let's graph what's going on here. So if x is greater than 3, that's this shaded area over here. Okay, we must use parentheses to indicate that the 3 is not included. We could also say that x is less than or equal to 1, so the parts that are less than 1 are shown here on the left. And we show brackets to indicate that 1 is included. Now there's no way that both of these intervals could be true at the same time. Say for example that x is -1. If for example x is -1, it would belong right there. And so the interval on the left is true, but the interval on the right cannot be true. So both intervals cannot be true at the same time. So this is a disjointed set. And when we're writing our interval notation, keep in mind that these are infinities. We're going to write each interval kind of on its own, and then we're going to unite the sets. So we have the -infinity. The first set is -infinity to 1, where infinity is not included and 1 is included. And we use a union operation for the other set, which is 3 to infinity, and neither of those are included. And the last thing we will say is just a little note about notation. In this video, we've used parentheses and brackets. So we've done, for example, this type of graph over here, which means that x is all the values greater than 2, but not including the number 2. Some books and some instructors like to use circle notation. So the way to indicate the same thing in circle notation is to just use an open circle. And the way to remember that is that because there's an open circle there, the 2 is not inclusive. Some instructors and some books like to use circle notation, while some like to use brackets and parentheses. Here's another example in which x is all the numbers greater than or equal to 2, including the number 2. So that's the notation we've used so far in this video. All of you doing circle notation, it's very similar. The only difference is you put a closed circle at the 2, and you still shade the same area. Again, the closed circle meaning that the number 2 is included.